Okay, looks like we're live. Hey guys, how's it going? Welcome to another episode of the Software Cooperatives meetup. Today we're talking about ephemeral DevOps. Wonder has anyone ever heard of that before? Um, I think it's going to be cool. We're going to have a real quick, high-level deep dive into DevOps. If you're like, what does that even mean? And then we're going to dive into this whole ephemeral piece. And so I think it's going to be fun. Without any further wait, Watson's going to kick us off.
Thanks a lot, Josh. Let's go ahead and start here. So Ephemeral DevOps, I don't know if you guys had a chance to take a look at the paper, and it's kind of a winding paper, and I'm sorry for that, but there's definitely some points here that coincide with software cooperatives and the things that we are excited about and what we try to promote as far as building coalitions, organic cooperation, these types of things. So it just so happens that within the DevOps community, a lot of the meetups that I would go to, talks, they touch on things that they kind of coincide or run parallel along organic cooperation, coalitions, these types of things. And so what I went ahead and did was come from the other side, but it took me a while. This paper took maybe a year just going back and forth with people. I maybe cut out 3/4 of it and just tried to trim down and make things a lot more succinct and not really get too much into the technical things. But let's dig into it a little bit. One of the one of the things that we have to go over first is the DevOps side. I'm gonna have to describe from a higher level what the state of DevOps, where we are right now, as far as what the literature says, and then where the community's at. With some of the newer tools like Kubernetes and some other things, what they're trying to do. And then I'm going to bring in some of the things that we talk about, like ephemeral groups, organic coalitions, cooperation, of course, those types of things. So things or cooperation that doesn't have a command and control type beginning. So that's when those two things come together, you get something that seems like it would be pretty cool. And then you kind of might just intuitively say, yeah, well, open source development kind of does that, but it's kind of halfway there. The social side is kind of there. The deployment side is just now becoming there, and then so how that ends up, coming into fruition with open source or in large orgs, it's we're gonna have to see how that pans out. But I'm kind of concentrated more on just the corporate side here, probably large orgs mostly, and but this I think will apply also to foundations like the Cloud Native Foundation or Linux Foundation, these types of groups where there's not really command and control there, but there's some resources there, and they know that they want to get some help. One of the things that they ask for all the time is, help with their CI. So there is a push for this type of cooperation. So it's interesting to try to reason about it. So let me just go ahead and try to describe DevOps in a more generic way. Right now, one of the biggest buzzwords is pipelines. You need to have a pipeline. So what I'm going to go ahead and do is define some of the components of a pipeline, and then try to describe a pipeline. Now I know from firsthand experience that describing a pipeline is kind of hard. People have different definitions. So I went through the continuous delivery book and grabbed some of their terminology. I also have my terminology. And I guess another thing that can be confusing is each tool has their own terminology. So Chef has a way of describing what orchestration or building out and deploying different components, what it should be named. We use GitLab that has its own terminology. I tried to take the specifics out, the technical specifics out, and reason about it or talk about it from a higher level. So while still staying true to the originators or the people who coined the phrase pipeline. So let's go ahead within DevOps and the state of the art, which is, for small orgs or small projects up to fairly large projects, your goal trying to get a pipeline going. So what we need to understand what an artifact is, what a specification is, and that's one that has different names or different terminology within it, and then how you describe your environments. Right. So artifacts, an artifact is really either a binary or a script that can be deployed. Right. So when we're saying that it's a binary or script that can be deployed, that means that when you put it on you take it from one machine, you put it on another machine, you configure the environment, you configure the application, but you do not need to install the compiler. For instance, you need to install a stack, but not the developer toolchain. Okay, so that's an artifact, and why that's confusing. We have interpreted languages like Ruby. There's no binaries. There's just a Ruby interpreter, right? So really, you just need the minimum Ruby interpreter, and that's it. And configure the environment, and then that's what a true artifact. Why is that important? When we get to define the pipeline, the artifacts are the things that move through the pipeline so each stage of the pipeline, right? So that's the thing that the developers create based off of the customers that have some feature request. They create this artifact, right? So these binaries, what have you, this is the output, and that's what gets tested and all these things, right? So that's the artifact. And of course, there's a review for the DevOps people, and then for other people, maybe not. All right, so specifications is where it gets a lot more confusing. So a specification, we're really talking about configurations, and there's different types of configurations, right? There's the configuration of the environment, there's configuration of the application, right? There's configuration of the operating system, right? There's the tricky one, configuration of the network, right? So each node. So when you start talking about the tools, like say a Chef or something like that, they have their own lingo, language, and way of describing the nodes, how the network topology is going to look and all that. But it's a specification. It's going to be some type of configuration, right? So you need to have, within DevOps, you need to have some way to describe how the world is going to look, all those different things, those configurations. It's important to separate from the binaries, right, from the artifacts, the configuration, because that's one of the things that allows you to have a pipeline. Okay? We're going to talk some more about that in a bit. All right. And then, of course, remember, keep in mind, all this stuff is so that we can create environments that are reproducible, they can be spun up quickly, and it reduces risk. So we'll talk some more about that in a bit too. right? So we have different environments. One of the things that within DevOps and then within the community, some of the talks that I've been in or witnessed, and then some of the literature I read, they hint on, hey, we want to be able to spin up these environments, these different environments. And regular development, some of these terms developers know, anyone that's within the technical side, you're familiar with the development side, the test environment, production environment, staging environment, those things, right? Another thing to add on is, and those would be the normal environments, but there's also a concept of experimental, exploratory environments, right? Those environments would be, and it's important to what we're talking about here, those environments would be a place where you can try something out, do a code spike, that type of thing, and not blow up production. And you're not, hopefully, if the way that the DevOps is set up, pipeline set up, all that stuff, hopefully it doesn't cost a lot for you to create this experimental environment, right? So if you can imagine, where's the benefit of that is, say, two orgs or two teams. One team makes a service. They are doing a new feature on a service. That's team one. Team two says, hey, maybe we should use team one service for this instead of Amazon service or whatever other service, or writing our own. Well, there's some risk associated with that, right? Oh, well, let's go ahead and use a specific commit that we know has passed tests and is deployable. Let's get that experimental build out there, and then we can deploy ours in there, right? So you're composing artifacts and specifications into one environment without hurting anyone, without forcing some other manager to give you their resources and these types of things, right? This is in the I would say perfect world where you have these just click a button, deploy type situations, which is what a pipeline what you're aiming for. So that would be this really almost zero cost experimental area where you can start composing things, experimenting things with things between teams, right? Which we're just now being able to do this type of thing. So this is where, where the DevOps community is trying to bring us. Okay, so those are environments. So now to talk about pipelines. So pipeline is a set of stages. So you take artifacts and you move them through these stages. The guys at ThoughtWorks thought that when they were developing this concept of pipeline, they were seeing patterns for wherever they were going, and they found that a set of stages were repeated through all of their projects. You can have more stages, more advanced stages that are, part of your custom build, but these stages that we're going to talk about in a bit, they seem to be pretty prevalent throughout all implementations. So we're not going to talk all completely define pipeline and get into the nitty-gritty for all of it, but these three things. So signals, what I'm calling signals, really the triggers, is what the continuous delivery book calls them. Pathways, that's the way that your artifacts move through, right? So those are pathways, what I'm calling pathways, the stages, right? And then within the pipeline, the reason why you're doing it is you're getting more efficiencies. So going back to what I was saying earlier, you have environments that can be spun up, experimental environments, production, all that. They can be spun up in a reliable way, quickly, and all that stuff, so that you can do multiple deployments in a day if you need to, or if you have an emergency, right? Security, problem, you can redeploy with your fix quickly. So some people don't need to deploy every day, but they still need to, but everybody needs, if they have emergency builds, they need to push them out really quickly. So, I mean, so both of those reasons are good reasons for having a pipeline, and they are help you with your efficiencies, or they are how you describe the efficiencies that are gained from a pipeline. Let's see here. So the example of a pipeline to just have these stages that I'm having, these 4 stages that I'm listing here, are the ones that the continuous delivery people said are prevalent throughout all of the projects that they saw. So there's a commit stage where, and we can describe it, but more later, but the commit stage is where the building happens. So the compiling for compiled code, the packaging for interpreted code. And within the commit stage, you also run some unit tests, maybe all the unit tests that the developers run, but not the automated acceptance tests. Next stage, right? And then for each stage, there's pass fail. Next stage, automated acceptance test. Those usually take longer, right? So those can take an hour. Commit stage, you're trying to keep them to 5 to 10 minutes. Automated acceptance test goes through and it measures the behavior that customers want to see. Commit stage, the tests are just the tests that the developers wrote as far as the unit tests, right? So one of the I guess some of the properties of a unit test, like the system doesn't actually have to be running, right? It just needs to, it's testing just different parts of the code. Acceptance test runs all the way through a feature. Then next stage could be an optional manual test stage. So you have QA testers that look through and do the things that humans are good at, which are, those things could be usability testing, exploratory things that, as far as trying to find pathological worst case scenarios, clicking all over the place and seeing what happens, those types of things. You still need manual testing for that. But if you're doing the continuous deployment stuff where there's no manual testing, you wouldn't have that stage. The release stage is the stage that goes, that creates the environment that's going to be production. It's the same as production. So that could be the showcase environment where you're going to show to users, but maybe it's not available to them, or it really is production. All right, so that's going a set of artifacts. So we're talking about pipelines. A pipeline is the implementation of a pipeline. There's a set of artifacts that runs through those stages. Right. There's other things that can be added on. It should be click button, right? So different people can just click a button and start the pipeline. It shouldn't be that it's hard to get the pipeline going. But the commit stage should happen immediately when somebody checks in and it runs the unit test. Those types of things. It should be publicly visible for everybody within who has an interest in the builds, the pass fail for each commit, right? So each build. But that's a pipeline, right? Right. So one of the concepts of the pipeline, which again goes hand in hand with this idea of like a zero or low cost environment, is the idea that you frequently deploy. And so there's a concept within the DevOps community that the more that you deploy, the less risk you have, because you're practicing, right? So if you deploy 100 times, deploying to production is not that scary. Okay? And then the other side is, at each stage, you're reducing the risk. So each commit stage to acceptance test stage to staging to production, you're reducing the risk at every stage. And each one of those is a deploy, right? So it makes things really efficient, because the people that want a build, they can get one quickly, and it also reduces the risk. So that's where you have a pipeline. So also, one of the concepts or one of the benefits of pipeline is now you can have a pull system. So you have developers who, like I was saying earlier, you want to grab a code base, a working code base from another team. You can do that at a click of a button. And you're the one that can pull that over and create the environment. You're not waiting for them to give you the environment. The testing side, well, for QA testing, they're not sitting around waiting for a developer or a team, DevOps team, to provide the environment for them. They can from all of the builds that pass the commit stage, they can pick from a few of them a subset of the builds that pass. So let's say they're testing the latest and it's bad, it doesn't work well in the testing manual testing phase. They can go ahead and select a phase previous, a commit previous, and then test that instead and say, oh, okay, this passed our exploratory and pathological testing. Let's go ahead and promote that to production instead, right? But they're the ones that can pull it over and do that work, right? And then the operations team can pull over given all this other information. They know that it's past the build, the commit stage, it's past the automated acceptance test, it's past the manual side. But the operations team can go ahead and move something into production at will, right? And so you have this concept of ownership of an environment based on a role, right? But you have people pulling in the work instead of command and control pushing out. So you have less wait time when you have a pull system, right? And then you can start concentrating on your bottlenecks and those types of things. But pull systems lend themselves to organic groups that they're autonomous. So they're trying to find work, pull work based off of other incentives, the customer demand or whatever, instead of the commands coming from on high to do something. So pull systems are promote more organic groups. Okay, so now that brings us into talking about there's a community, cloud native community, where it's kind of a broader idea, like building on some of the things from, say, 12-factor applications, things that are built so that they work well in the cloud, microservices, these types of things. And so what you get from that is not only just these environments that are from the DevOps community, and what they want to have is environments that with pipelines, everything, where people can pull and set up environments quickly and all that. From the cloud native side, what you have is environments that are reliable. So when you push things into a cloud, you have all of these things that allow for production level services, right? So some of the things cloud native community enforces or desires is reproducibility, resource isolation, transparency, monitored failures, distributed data caches. So all that stuff is technical implementation ideas and methods that work well in the cloud. Okay, so those are when you do those things, you have a reliable service. So now you can have things, and then some of the tools that they use, Kubernetes and Docker. You guys, some of the technical guys are familiar with that. They lend themselves, or even like Kubernetes is even within the cloud native foundation. So these are this is the direction that development is going for large applications, right? So now on the social side, let's start talking about the cooperative and the organic and all this stuff. So decentralization, some of the things that might be reviewed for people familiar with our ephemeral groups paper. A decentralized team is one with just very little hierarchy, right? So command and control, smart guy on top, everyone else, just does what they say, right? Organic, the idea is that there's a group or an individual, right? And it's autonomous, and it rises and emerges based off of need. Okay, so this kind of thing can happen pretty easily when there's not a lot of barriers to emerging or to coalescing. But within development, there's lots of barriers. It's like, hey, let's go ahead and use this other group service. Oh, well, we've got to get the servers for that. Oh, we got to compile our code for that. Oh, we got to, and so there's 50 million things, including red tape, right? And we'll talk a little bit about that later. But maybe they want to, they're playing with the cards close to their vest. They don't want you to have their code, right? Because, they're empire building. All these things can stop a group. But now with the DevOps movement, cloud native pipelines, that stuff is opening up. So now you can have these groups, and they don't need to have command from on high that tells both groups to act right. They're just already developing in such a way that all the artifacts and the environments and everything are out there for you to pull, right? So ephemeral group. It's the difference. Ephemeral group is a specific thing. We talked about it before. We have another paper on it, another YouTube video on it. But it's a coalition that comes into existence just enough time to pursue an opportunity, and then it dissolves. Why that's important is, lots of people think about groups coming together and working on some type of task, but they don't often think about the groups dispensing later. So when you have an ephemeral group, when we're talking the cost of doing a task or implementing a task, it reduces because they don't need to have, if they're W-2, you don't have to continuously pay them for something that's already built, right? There isn't a long-term cost. It's just one cost to build this thing out, and the long-term cost for maintaining it could be lower, right? It could be one person maintains it, not 5, right? But you come together, 5 people can come together and build something, and then they can go back on their merry way, right? That's the concept of a ephemeral group, and it should be kind of trivial to understand that it's less of a cost, less of a risk, all these things like that. So now we come into this idea of what happens when you take a cloud native, right? So cloud native is when you, again, for what we were saying earlier, it's not just the DevOps side with the pipelines and everything is click button or easy to deploy. It's also reliable, right? So reliable, production ready, lots of users, high hits per second, that type of thing. And combine that with the ephemeral groups, you can have the situation where people are coming together and creating a service, microservice or what have you, in a small amount of time, putting it out there, and then going back to their regular groups or whatever. That's just now becoming possible. Whereas before, that would be an expensive thing. Okay, there's too much risk involved and all these things, right? So now you can have something with that type of development. You could call it ephemeral native, right? So a combination of ephemeral groups and cloud native, right? And so together, the environments get spun up. They're elastic. They also disappear. So you're not long-term paying for something. the groups spin up. They work on the service, and then they can disperse. And in the long term, you're not paying for something, right? So those two things can come together. Now there's new opportunities, whereas previously an individual can go and tinker, and maybe because they have a lot of political capital, they get a bunch of resources and they can try code spikes and all that. Usually this is for the mad scientist of the group, that they're allowed to be the skunk works. Now you don't have to have a designated political capital person. You can have a group and they could just come together, try something and disappear, low risk. Whereas before you couldn't, right? And so why is that important? One of the things that gets around is the Innovators Dilemma. We talk about this a lot, but just for review, Innovators Dilemma is simply, you can think of it like this: good management obeys customers' desires. Customers desire more of the same. Therefore, good management obeys the desire for more of the same. What does that mean? Right? Because it's a paradox. Good managers will give customers the least risky thing that the customers ask for, right? They're not going to take the customer's money, right? Because the customer asked for a specific thing, and do something risky, which is innovation. It's something different than what they asked for. Those two things are the paradox hidden within the Innovator's Dilemma. That's why you can have a good idea. Well, another way to describe it is if you're at IBM, depending on the size of the company, you're at IBM, you have an idea for saving money. You say, yeah, this can save us $50,000. It's not going to change anyone's mind. They're not even going to pay attention to you. You have to say, it's going to save $1 million. And then someone would turn their head, say, oh, okay, let's see what you have to say. That's what happens when you have an innovative dilemma. It always happens in large groups, right? So everyone has a threshold. Every organization has a threshold where the good management is going to be always trying to do what the customer says, right? Because customers, they're the ones with the resources and everything like that, right? What happens with the ephemeral group or people who are innovators and all that, they can go about, they can say, okay, let's take the idea of, I don't know, let's say an iPhone. When I always think of an iPhone, the customers didn't want a phone that had no way to change the battery at the time. Everyone said that was stupid. Okay. Now, Steve Jobs said, no, we're going to have a phone. You can't take the battery out. You can't change it. Right. And everybody thought it was cool later because the phone was thinner, all this stuff like that. Well, in this situation, this example, it could be a group comes together. If you can imagine, a group could come together, create a prototype, right? And say, okay, we're going to try a phone with no screws in it, right? You can't take the battery out. That would be an example of a group of people trying to innovate, right? Where the customer says no, right? Based off of all kinds of different reasons. And this is a big debate. So some people think you should go completely always doing what the customer says, right? And they just don't care about the Innovator's Dilemma. And then there's the people, like I said, like I just gave you an example of Steve Jobs, right? So the ephemeral group people aren't beholden to what the customers say they want. They can go ahead and try to provide in a staging area, showcase, hey, what about this? Would you pay for this? That kind of thing, right? So they can get around it, right? And then the silo disruption is a situation where they were saying earlier, you've got two organizations or two teams within an organization. They're doing empire building. One side says, why should we share information? It could be intentional or unintentional, right? Team A could say, hey, if we start providing services for everybody, and this would be intentional, we start providing services for other people, they're going to expect us to provide services for them, right? And so we're going to be working hard for no reason. So let's just act like we can't do it. Go ahead.
Nothing. I was just laughing. So true.
Yeah. Yeah. So there's plenty of reasons, and if you like, if you're interested in this concept, Patrick Lencioni has a book on it called Silos. So, but yeah, it's just groups form, people draw lines, and it's insiders and outsiders, and it's empire building, right? But it also can happen unintentionally. So just for people just being slothful, right? Just lazy, right? So DevOps reduces this friction, reduces these barriers, and so people can start trying to go around these silos and providing value based off of, customer desires, or maybe some long-term problem they were trying to fix, but they need to just go ahead and do this small term or short term service, right? That everybody's just saying, oh, we don't want to do it, you do it. That happens a lot. Group can come together, let's just do it. Let's do it for free on our own time, put it out there, but we need to grab all their code base. Okay, well, with the DevOps side, you can do that. And with the cloud native side, it can work in the real world if it's, a large application. So in conclusion, previously, I've always saw this in my career. I'm sure people have been around, have seen it, where, if there's a problem, you got either silos or lots of red tape. One person can an enterprising person can say, I'm just going to fix it. And it can go through sheer force of will on their own time. Could be a code upgrade, right? No one wants to pay for the big rewrite. Somebody just goes off and upgrades the code on their own, right? That's an example of what and one individual can do that, might require resources or whatever. Different things like that. Used to be individuals, right? And that worked, right? But there's a threshold that they can't do. Something that would take 5 people to do, right? Maybe you need special environment, right? You need 3 different services to compile and be deployed for you to do your fix, right? These types of things, and regular individual, they might not have the permissions to do and all that stuff, so they just can't get there. Now you can have a cross-functional team come together, do this type of fix, and then separate. Whereas before you didn't have that, right? And this is, like I said, this is becoming possible because of pipelines. This is becoming possible because of the, within pipelines, a concept of everyone being able to see the status of code, pick a certain commit, deploy it, those types of things, right? And now also organizations are getting flatter. There's more autonomy, letting people do kind of what they want, maybe not for years at a time, but maybe now, people can do what they want for a month or months at a time, as long as they come back with something very useful. And this type of thing, groups now can come together, do something amazing, and put it out there, as a microservice or whatever. And, and then disperse, go back to wherever they want with zero cost, zero risk, all these types of things. So that's a concept of the ephemeral DevOps. Any questions?
Okay. Hello?
Yeah.
More so a comment than a question. I don't know, I think it's cool that I don't know if it was like I guess like they say, what do they say? The truth. The truth is the truth, no matter where it's being told. And so it's like, the pipelines and this whole wave of DevOps come about because software it's easier to develop software that way? Yes, I think so. But then it's also probably easier to work that way. And I mean, we're in a software cooperative. We think it's easier to work as a cooperative already. And so it's kind of interesting to see that like the software and the environment is just trending toward that way. It's almost in support of it. I think it's cool.
Yeah. Anything else?
Appreciate it. It was really interesting for me being, I guess, on the DevOps side has been where most of my career has been, seeing everything fully from the other direction. I started from software, but I've been primarily in DevOps for a long while, so hearing it come fully from that side is pretty cool. And hit a lot of the same concepts that interest me, which is about, I guess, the philosophy behind this. DevOps is a name that is covering a lot of the ideas that a large group of people were trying to implement, and there was no name, so that people would have different titles, and you'd end up doing stuff where people don't really understand why you're doing it, but they know when you don't, then their life is harder. And the different groups are having a hard time to communicating and interacting. So a lot of this, what you're saying as far as the reducing risk is part of that, and being able to communicate between groups. So like the consumers wanting something and then someone trying to get that, and then the innovation on one side, and being able to tie all that together. And I guess different risks that different groups have as software becomes more complex. So how do you get all those things tied together? It's not just the software complexity, but the domain and the understanding that someone has, and how do you communicate that between the groups. So that flow of communication is where the tools start coming in. How do you do it? And I think you hit pretty strongly on the philosophy side, which is my primary interest. And you came at it through the tools, so that was pretty cool for me. You with us, Christian?
I'm with you, yeah. I'm listening. Very interesting insights.
Yeah, what are your thoughts? Yeah, it was very interesting for me to hear this from being inside of it. What did you take out of it?
Well, I'm pretty much, I don't know.
Is it hitting a lot of the concepts that you've been familiar with?
It does. I haven't been familiar with the terminology that much. That's that's new for me.
Yeah, the operations side. So Christian's background, for everyone, is deep on the operations side. So a lot of that reducing risk, and what a lot of this paper and talk was about is bridging that operations and infrastructure, and how do you get the development into the operations side, and working together to have the product out for people to use, and then how do you have the product available for development in different groups. So yeah, thanks, Watson.
All right, no problem. And I've got a bunch of mind maps that I'll upload for just specific to pipelines. For this too, I'll put them out there in the.
Great.
I'm gonna click stop here. All right.
So,